Glycogenesis. This is a biochemical pathway that enables the formation of glycogen. Hello and welcome back to the channel. If you watched our last video, glycogenesis might sound familiar, because in the last video we've talked about glycogenolysis. So, first, glycogen is an important word here. So, this is the primary source of carbohydrates in the liver and also in muscle cells, which is formed from glucose. Here you see the structure of glycogen and here of glucose. Now, glycogenesis is the process where glycogen is used as a form of short-term storage from abundant glucose. And in contrast to fat cells, which are intended for long-term storage, glycogen is readily available. And as soon as the blood sugar levels drop, glycogenolysis gets induced, which is the process where this glycogen is then broken down into glucose again. And if you want to watch this video about glycogenolysis as well, it's linked above. Now, let's talk about the steps in glycogenesis. So first we have to convert glucose into glucose 6-phosphate via the enzyme gluco or hexokinase, depending on whether we're talking about liver or muscle cells. Now, then we convert it into glucose 1-phosphate via the phosphoglucomutase, and then we form UDP-glucose via UDP-glucose pyrophosphatase. Then, as soon as 7 of those molecules get added to a tyrosine residue of glycogenin, which is another enzyme, new UDP-glucose gets added by the glycogen synthase. And, well, usually we're only talking about alpha-1,4 bonds, but there are also branching enzymes which can form alpha-1,6 bonds. If you want to know more about that, again, you might want to watch the video about the glycogenolysis. Now, actually, the need to store glucose and, well, in this form also energy is obvious, but this is not feasible in form of glucose. The paramount reason for that is that obviously cells want to take up glucose if it's available as such. And glucose attracts a lot of water, as you see here. So every glucose molecule needs a specific amount of water. Glycogen, on the contrary, packs many glucose molecules into one, and this without the need for suspending it in water. Actually, otherwise the cells would need to hold so much water that they would burst, and this is not possible. Well, so now we know what it is, but when do we need glycogenesis? So it's a process that is regulated by hormonal stimulation or downregulation depending on the context. And it's usually about the respective enzymes which are under the control of hormones, which then can initiate a reaction. And one of the important hormones here is epinephrine, which is also known as adrenaline. And this gets released during fight-or-flight responses. It actually downregulates glycogenesis because we need the energy resources and we cannot store them. Another important hormone is glucagon. And an essential hormone for initiating glycogenesis is insulin. Insulin gets released when there are a lot of nutrients in the blood. And by forming glycogen, the amount of glucose within the blood gets reduced. And when we're just taking a brief look at the molecular level, the regulation of the enzyme works by phosphorylation via CAMP and also via the protein phosphatase. The enzyme is active when it's not phosphorylated. So, and we need glycogen because it can store enough energy to provide a constant blood glucose for up to 48 hours during fasting periods. So, glycogen is predominantly stored in the liver, but some is also available within muscle cells. When we're taking a look at the capacities, the liver has in total a greater one. But as usually we have more muscles than liver tissue, there are 3 to 4 times more glycogen in myocytes, so in muscle cells, than in hepatocytes, which are the liver cells. And another key difference is that hepatocytes can release glucose 6-phosphate and thereby support other organs with it, while myocytes use it exclusively for their own supplement and therefore for muscle contractions. And there's also a certain clinical significance here because there are certain disorders concerning glycogen storage capacity. Some of those are comparatively mild, others have more severe consequences. So this was a brief overview of glycogenesis. You might want to watch the video about glycogenolysis as well. I hope you enjoyed this video. If so, don't forget to give it a thumbs up and to subscribe to the channel to see weekly uploads on highly relevant scientific topics. See you in the next